last meeting, ang discuss natin ay chaos and hysteresis. Ang kombinasyon. Ngayon ay discuss naman natin ay kukontinue lang natin yung discussion natin sa tawag dito sa chaos, okay? And in particular, titignan natin kung paano nag-a-arise yung chaotic behavior ng isang system. Okay. And to be able to describe kung paano nag-evolve yung chaotic behavior, we're going to look at this concept of mapping. So, pag sinabing mapping, basically, we are looking at the progression of tawag dito, the behavior of a nonlinear system with respect to time. Okay, and the way to do that is we're going to solve for. So the way to do that is titignan natin kung ano yung nangyayari sa n plus 1 state, okay, from the nth state. Okay, so we're looking at progression, okay, of a system. Okay, pag sinabing progression, it can be anything. Okay, progression ng tawag dito, population, for example, progression ng temperature ng isang system, okay, ng droplets ng water, okay, and so on and so forth. Any kind of system can be modeled or can be mapped, okay, using this technique. Okay, so what we're going to do is what's called mapping, okay, and yung idea ng mapping is we get what is happening at the state x sub n plus 1, okay, from the state x sub n. Okay. Now yung state na x sub n is described by this function. Yung function na yun ay dependent dun sa state na x sub n. Okay. Well, in general, tawag dito, there's another parameter that we need to add, okay, para makuha yung n plus 1 state, and we call this parameter alpha. Okay, and itong alpha na to is numerically it's a real number, okay, between 0 and 1, and it can describe tawag dito, well, it can be attributed to some physical variable, okay, and maintindihan yan better mamaya pag nag-discuss tayo ng isang example. Okay, now, of course, yung x sub n na yan is yung nth state ng system, okay, and we want to get the n plus 1 state through this function or through this process called mapping. Okay, now, ang example na i-discuss natin ay logistic mapping. Okay, and the reason why it's called logistic kasi gagamit tayo ng logistic equation, okay, which is given by alpha, okay, x sub n. So alpha x sub n, 1 minus x sub n. So this will be the equation that describes the way we are going to get x sub n plus 1. Okay? So, paano natin ngayon gagawin yan? So, syempre, magsiset muna tayo ng value for the parameter alpha. So, we set this value. Depende kung ano yung physical system na minomodel. And then, we also set the initial value of x. So, set x sub 1. Okay. So, we set x sub 1, we set alpha, then makukuha natin yung x sub 2, tapos makukuha natin yung x sub 3, and so on and so forth. X sub 3 from x sub 2, and so on and so forth. Now, if we plot x sub n plus 1 versus x sub n, what we get is some sort of parabolic behavior. So, ganito yung magiging itsura. Okay. Dun sa taas, yan yung plot ng x sub n plus 1 with respect to x sub n. So, ganito nyo intindihin yan. We begin with x sub 1, kasi di ba nagsiset tayo ng value for x sub 1. And then, we project that x sub 1 dun sa parabolic na curve. Okay, and then, from that parabolic curve, we can get x sub 2. Okay. Once we get x sub 2, lalagay natin ngayon siya dito sa x-axis, sa horizontal axis, i-project natin yung x sub 2 dun sa parabola, and then we get x sub 3. Again, we determine kung nasan yung x sub 3 dyan. Okay, and then we project it to the parabola, and then we get x sub 4. Okay, and so on and so forth. So it turns out that this logistic function, anong tawag dito yan? This displays this parabolic behavior if you plot x sub n with respect to x sub n plus 1 with respect to x sub n. Okay, there's another way to plot it, and siguro an easier way, and the way to do that is draw a line that is 45 degrees. Okay, malalaman nyo naman na 45 degrees yan kasi ang gagawin nyo lang naman is tawag dito, ito at saka yan ay equal, ito at saka yan ay equal, di ba? So yan at saka yan ay equal. So 45 degrees yung ano line na yan. Okay, and to use or to understand kung anong nangyayari, again we start from x1. So we start from x1, then we project it dun sa parabola, and instead of going to the left, pupunta tayo sa right, and we project that dun sa 45 degree na line. Pag nakuha na natin yan, this is actually x2. Okay? The same x2 na dun sa taas. Okay? And then, i-project nyo yan sa parabola, and then go to the right, then we find x3. Then dyan pataas, then we go to the right again, then this is x4. Okay, so that's another way of tawag dito, determining yung values ng logistic function. Okay. It's easy to see that here kasi pag dito naman tayo naglagay ng ng 45 degree na line, then what happens is that imbis na magle-left ka, di ba, magra-right ka. So magtatama siya dyan. And dito, tatama siya dyan. And dyan, tatama siya dyan. Okay? So pareho lang yung interpretation. Okay. Now, sige, that looks interesting, but what's more interesting is, so dito ang binabago natin dito is yung tawag dito yung x sub n, di ba? Or binibuild natin yung x sub n. What if we look at the behavior of the function f with respect to alpha? Okay, tignan natin yung behavior ng function f with respect to alpha. Okay? Ano ang makukuha natin ngayon na graph? What we'll get is something like this. So this is called a bifurcation diagram. Okay, and the reason kung bakit bifurcation diagram yan kasi at specific points, halimbawa dito sa point na ito, nag-split, di ba? Ang cooler na term dyan is nagba-bifurcate. Okay, so kaya siya bifurcation diagram. Then, at this point, meron ulit bifurcation. Okay. And then meron ulit bifurcation dyan. Okay, so at specific values of alpha, so yung x-axis is alpha, and then yung y-axis is x sub n. At specific values of alpha, merong bifurcation. Ngayon, nakikita nyo na beyond or from here going to higher values of alpha, medyo hindi na natin na alam kung ano nangyayari. And we attribute that to chaos. Okay? So yan yung chaotic behavior. So we start from this line that's easily determined, diba? From the equation, from the logistic equation. Tapos biglang magkakaroon ng bifurcation. And that's already the beginning of chaos. Okay? Kasi ano ba yan? Ano bang size niyan? Di ba? Paano natin na-determine kung ano yung size niyan? Ano yung reason kung bakit ganyan yung size? First of all, ano yung reason kung bakit siya nag-split? Well, bifurcate, di ba? Mas maganda pakinggan yung pag nasa jeep kayo. Okay? So, ganun yun yung nangyayari dyan. Okay? And when you vary the initial conditions, nagbabago rin, nagsishift lang ng konti yung mga bifurcation points. Pag sinabing bifurcation points, itong values ng alpha kung saan nakikita natin yung kung saan nag-start yung bifurcation. Okay? Okay. So, hindi yan ganun ka, well, interesting siya. Okay, but siguro for you to better appreciate yan, okay, I made another MATLAB file, okay, para makita nyo kung anong nangyayari talaga. So stop ko muna yung pag-share dito. And share. Any questions so far? Okay, it's good na malakas yung audio niya. So. Okay. Yan. So i-zoom in natin ng konti. And tingnan natin ito. Okay? So, andyan yung description ng logistic map. Lahat ng describe ko for the first 15 minutes or 20 minutes. Hindi dyan lang din. Okay? So you have this logistic equation. Okay? And then we have this parameter. Ito, kita-kita nyo naman na yan yung logistic equation. Right? And I set up 30 points. Okay? Meaning, yung progression is just 30 data points. Okay? And since it's progressing, we just refer to it as time. Okay? So in other words, yung 30 yung data points dito. Yeah, 30 yung nakikita niyo dyan. Okay? Now, yung R value dito, or yung alpha value dito, by the way, I changed the value from alpha to R, the parameter from alpha to R, kasi in this particular example, ang minomodel natin dito is yung population, okay, ng isang, population ng isang species, kung gusto yung isipin. Meron sa book, nagre-refer siya sa population ng rabbit. Okay? And kung gusto nyo isipin na ganun, so ang idea dito is that itong x sub 1 is yung initial na population, and then yung R is interpreted as the growth rate. Okay? And pwede natin baguhin yung growth rate dito, and pwede rin natin baguhin yung initial population para makita natin kung ano yung nangyayari dito sa graph. Okay? So if I change this, for example, to lower values, then I get this graph. So yung error. Bakit siya may error? Anyway, mamaya pa naman yan. So, ano nangyari dito? So, yan. So, yan, 1.1. Yan yung sa 1.1. Ito yung sa 1.5. Okay? So, nakikita nyo na maganda pa yung ano, di ba? Yung population decay. And population decay siya kasi nag-start siya from this initial population and then bumababa yung population niya. So for this growth rate, okay, it's not actually a growth rate, but it's a decay. It's a decay rate, di ba? Pero habang ini-increase natin yan, let's say 2.1, makikita nyo na at some point, magsisimula na mag-reproduce yung mga rabbits. Okay? Pag in-increase pa natin yung growth rate, so ganyan na yung nangyayari. And if you increase it further, up, sandali. Huwag muna dyan, konting-konti lang. Oops. Ano nangyayari? Hindi na yata siya gumagalaw. Ayaw niya nang mag-grow. Okay. Okay, anyway. So, makikita niyo na dito na sobrahan ko siya, naging 2.6 yata or something. So, pag umabot na sa ganong growth rate, anong nakikita niyo? So, imbis na smooth line lang, ang nakikita niyo ngayon is jump siya from these 2 points. And if you graph this point, so ito yung isang point, pag susundin niyo itong points na ito, you actually see yung splitting. Kasi yun sana yung gusto kong maipakita dito. Yan. So 1.8, 1.9, and then 2.1. Ayaw pa rin niya. Okay. Well, anyway, aside from yung MATLAB, itong MATLAB file, ayan, 2. Ayan. So 2.2, ayan, nagsisimula ng magkaroon ng bifurcation dito. So doon, and then dito sa baba, and then dito, and then bumaba siya, and then gano'n. Okay, so meron parang cyclic na motion, and if we plot it with respect to R, and if we change R later, makikita natin na magsisimula siyang mag-split somewhere around this value, or makikita natin yung splitting siya somewhere around that value. Okay? So, if we also change the initial population, so mas nagiging sharp yung yung lines, nagiging sharper ba? Hindi. Well, anyway. Kapag ng technology. Dito supposedly makikita niyo dyan yung parabolic na graph. Okay, na pinakita natin kanina. Now, dun na tayo sa bifurcation. I hope we have more success there. Yeah. Anong problema na naman dito? Okay, anyway. So, isi-send ko naman sa inyo ito. Pwede niyo paglaruan yan. And makikita niyo kung paano nag So, bakit ito may bifurcation? Kasi nagsisplit ito. Okay, so nagkakaroon siya ng splitting dito. And yung splitting na yun, so dito maliit pa yung splitting sa 2.2. Pag in-increase niyo yung growth rate, palaki yung splitting na yan. Okay, so banda rito, yung 2.2 is somewhere here, so hindi obvious yung splitting eh. Pero pagdating sa mga 3 or 2.9, yung graph na ito will be ganun. Okay, mas malaki na. Okay, and if you increase it further, lalaki yung splitting, and that splitting is seen here. So ito yung actually yung splitting nakikita dyan. Okay, and then pagdating nyo dito, magiging 4 yung magiging 4. Okay. So yun yung nangyayari dyan. So you can play around with that when I send it. Okay, but siguro for better appreciation, panoorin nyo na lang tong video na ito. Siyempre, meron tayong video. Just from this simple equation, ang dami niyang pwedeng i-model na physical system. Right? So, tulad ng sinabi niya, maganda rin na batuhan kayo ng chaos paminsan-minsan. Yeah. So, yun yung ginagawa natin dito. Oh.
Okay na ako sa easy.
Okay. So from this, from this simple equation, we can from this simple deterministic equation, pwede siya mag-evolve into a chaotic na system. And it's not just itong logistic expression na ito yung nagbe-behave na ganito. So marami pang mga iba. Katulad ng pinakita niya kanina, okay, it's x of n plus 1 is equal to sine x of n. Okay, is another example of an equation that tawag dito, that can be mapped. Okay, yun yung pinag-usapan natin, mapping. Okay, so marami pang iba't ibang equation which exhibit this chaotic behavior. And who knows kung ano pa yung mga ibang applications na pwedeng paggamitan dito. Right? Malay nyo, habang naglalakad kayo or natutulog kayo or napanaginipan nyo or tawag dito, nagsuscroll lang kayo sa cellphone ninyo at kung ano-ano man, may makita kayo, teka lang, parang nagbe-behave to ng ano. Yung scrolling ko, pag nagbabifurcate, di ba, nagkakaroon ng, nagdo-double yung frequency ng thumbs ko Diba? So yung ganun, eventually pwede yung maisip nyo na, pwedeng gawin thesis to, diba? So yun yung isang tawag dito, pwede nyo i-consider. Okay? Okay. There's another way to quantify tawag dito. Well, nakita nyo rito na yung chaotic behavior depends on the initial conditions. Okay? In addition to yung alpha na parameter. Okay? So there's another way to quantify yung dependence ng chaotic system sa initial conditions. Okay? At ang tawag doon ay we can quantify that using an equation, and tawag doon sa equation ay Lyapunov characteristic exponent. Okay, so Lyapunov is the name of a Russian mathematician na naka-discover nitong naka-discover nitong equation na ito. Okay, so ang idea lang dito is tawag dito. So we're looking at initial states. So let's say na ito yung initial state na pinag-aralan natin, and then nag-evolve siya into a chaotic system. And if you change that state to some other value, okay, so we change that state from x naught to x naught plus epsilon. Yung epsilon is just a small number, okay, na paboritong-paborito yung gamitin sa Math 53 tsaka Math 54, di ba? Okay, so this is just a small number. So nag-shift lang ng kaunti yung initial condition. Okay, ano yung mangyayari? Okay? So sinabi ni Lyapunov, okay, na pwede niyo i-model yung behavior na yon using itong equation na ito. dn is equal to epsilon e to the n lambda. Okay. Ano yung tawag dito mga parameters na yan? Of course, yung n is the number of iterations. Or yung progression. Okay? Or dun sa example ng population ng rabbit, it's the time. Okay? 1 year, 2 years, gano'n. Itong lambda na ito, okay, so this represents yung coefficient of the average exponential growth, okay, per unit time. Okay, between two states. Okay, and so after n iterations, yung difference, okay, yung difference dun sa between the two states from difference na nakukuha nyo between x naught na initial condition at saka yung x naught plus epsilon na initial condition is d sub n. Okay, yun yung sinasabi nito. So d sub n is the difference between using x naught and x naught plus epsilon as initial conditions. Okay. Obviously, pag epsilon is 0, then walang difference, di ba? Pero kung mag-multiply ka ng maliit na value dyan, magkakaroon ka ng small na difference. Okay? Okay. Also, what we see here is that if lambda is negative, okay, then ano masasabi niyo about d sub n? So meron kayong negative exponential, yung d sub n ay magdi-decay, di ba? So anong tawag dito? So, parang counterintuitive yun kasi nga nag-introduce ka ng epsilon, nag-introduce ka ng change, pero ang nangyayari is lumiliit yung difference, di ba? Pero so hindi yun yung parang ine-expect ninyo. Okay? So pag ang lambda is negative, it cannot be interpreted as some physical. It cannot be interpreted physically. Okay? So gusto niyo na ang lambda is positive. Okay, so tignan natin. Let's take a look at, let's say, na compute natin yung unang difference. Let's say na yung unang difference is d naught. Okay? And after one iteration, so d1 na, di ba? d1. Okay, ano yung value ng d1? So d1 is equal to, so sabi natin x sub n plus 1 is described is equal to f sub x sub n. Di ba? Ito yung ating mapping equation. So, and remember dito, meron dyan incorporated na initial condition. Di ba? Initial value, which is x1. Okay. So, pag yung initial value yung ginamit yung x1, ang makukuha nyo ay epsilon. Pag pinilitan yung x1 ng epsilon, ano yung d1? Okay, yun yung gusto niyo malaman. So essentially, yung function na yan ay dadagdagan niyo lang ng epsilon. Di ba? Kasi binago natin from x to x plus epsilon, right? So the function fx plus epsilon is the new tawag dito is the new mapping function. Ano yung old na mapping function? F of x sub n. And yung difference, okay, is d1. Okay? Okay? So, yan yung ano dyan. Yan yung tawag dito. Well, ganyan natin siya i-define. Now, from math 53, pwede natin isulat ito. Epsilon df dx. Okay lang ba yan? Kasi di ba, recall from math 53. Oh, shit, hindi na tayo nagre-record. Wala na yung Zoom. Record ko pa ba? Okay. Nagre-record naman pala pero hindi lang naka-share yung screen. Okay, so naririnig niyo lang. So, So, from Mat 53, di ba? df dx is equal to the limit epsilon approaches 0 ng f of x plus epsilon minus f of x over epsilon. Tama? Brings back memories ba? Right? So pag inangat ko lang yung epsilon dun sa tabi ng df dx, then we get this equation. Right? Right? Okay. Okay. So if we keep changing yung initial condition, okay, n times, then we end up with dn is equal to fn x plus epsilon minus fn x0. X na. Okay. So pinalitan natin yung initial condition n times. Okay, so ibig sabihin, kukuha tayo ng derivative n times. Okay? Now, asan na yung sinulat ko? Now, this equation, ano ba sinasabi ng equation na ito? Yung equation na yan, okay, tells us the difference after n iterations. Di ba? Kaya nga may n dyan eh. Di ba? Number of iterations. So d sub n is the difference after n iterations. Which means na ito ngayon is equal to epsilon e n to the lambda. Okay. Okay. Now let's solve for lambda. How do we solve for lambda? Siyempre kukunin natin yung natural logarithm. Okay, kukunin natin natural logarithm on both sides. Specifically dito lang sa part na ito. Okay. Yeah, diyan lang sa part na yan. Kunin natin yung natural logarithm on both sides. So we have ln ng fn x plus epsilon minus f of x naught over epsilon. By the way, nilipat ko yung epsilon sa kabilang side. And then we have yung ln ng exponential n lambda. Okay. So this becomes n lambda. So lambda therefore becomes 1 over n. Tama ba? ln ng fn x plus epsilon minus f of x naught over epsilon. Okay, and since nag-differentiate nga tayo n times, essentially that is essentially the derivative with respect to x ng pag-apply ng function n times. Okay. Okay. So yung tignan nyo yung n wala dun sa ddx So isang beses nyo lang actually tinik yung derivative. So it actually means this way. So df dx, okay, nung kinuha niyo yung x n minus 1 multiplied by df dx, nung kinuha niyo yung x of n minus 2 hanggang sa df dx, nung kinuha niyo yung unang-unang ano tawag dito? Unang-unang initial condition. So ito yung x naught, ito is parang x naught plus epsilon times n minus 2 times, tapos ito ay x naught plus epsilon n minus 1 times. Okay? So ganyan yung ganyan. So we'll end up with lambda is equal to well, we take the limit as n approaches infinity of 1 over n, and then yung sum from I equals 0 to n minus 1 ln ng df xi dx. Ngayon yung equation na titignan natin. Okay? Now, okay lang kung hindi nyo ganong maintindihan yung mathematics. Ang importante maintindihan nyo yung process. Okay? Kung ano physically yung nangyayari dito. Kasi remember, ito yung walang change. Yung next dito is change natin to anong tawag dito? Change natin ng epsilon, and then yung susunod change natin ng 2 epsilon, okay, and so on and so forth. So kaya yung bawat change na yun ay minimultiply natin sa isa't isa. Okay, yun yung ginagawa natin dyan. Okay? And alam naman natin na when we do differentiation, kinukuha naman natin yung limit, okay, as n approaches infinity. N approaches infinity. Okay. Now, ano ang yan? Ibig sabihin niyan? Well, if we graph that, yung f, remember na yung f is actually f of alpha x sub n. Now, if we graph lambda with respect to alpha, okay, ito yung makukuha natin. Now, from here, we have this Lyapunov exponent. By the way, yung lambda na yan yung Lyapunov exponent. And that's one way to determine kung anong tawag dito? Kung chaotic yung system or hindi. Mafi-figure out niyo ba from dyan kung chaotic siya o hindi? Just by looking at the graph. Well, parang sa behavior pa lang ng graph, alam niyo na kung saan chaotic at saka kung saan hindi, di ba? Saan? Above the zero line. So pag ang lambda is less than 0, stable yung system. Pero pag lambda is greater than 0, chaotic na yung system. So itong Lyapunov exponent is a way to quantify kung chaotic or stable yung system. Okay? Nakalagay din naman sa caption kung binasa nila. Okay? Okay? So, yeah. So yun yung dyan. So to determine that, of course, kailangan niyo yung function na yung function na f, kunin niyo yung derivative, kunin niyo yung natural logarithm, isum niyo for all changes, di ba? And then kunin niyo yung limit para makuha yung value ng lambda. Okay, any questions? Yes.
So, di ba sabi nyo kanina, kapag nag-negative yung lambda?
Pag nag-less than 0. Tama, pag nag-negative.
Hindi siya ma-explain physically. Or iba yung lala.
Hindi, tama yun. I mean, in terms of chaos, mukhang mali yung pagkasabi ko doon. In terms of chaos, pag negative yung lambda, hindi siya chaotic. Mas feasible yun ang explanation kaysa yung sinabi ko kanina na walang kwenta.